my online kids real quick, and then we'll go over, just have people that are dinging on right now. I don't know. We got one more set. That'll be Monday too. And so yesterday we started metamorphic.
Students for the introduction for morning update. We welcome all of you to Hazel High School this morning. For your safety and the safety of others, please note that health pre-screening is required for every person before you enter the campus. Also, Hazel ISD and Hazel High School will follow all Tarrant County public health guidelines as well as all CDC requirements. School safety is a top priority for Hazel High School and Hazel ISD. Faculty and students, if you have any questions at all regarding school safety, any questions, please see one of our officers in the hallway or see one of our administrators in the hallway. We'll be glad to assist you and help you. We ask that everyone in our building, please wear a face mask that covers your mouth and your nose at all times in the building and in school activities. We appreciate this for your safety and the safety of all of us. Also, students, it is a district requirement that you wear a visible ID around your neck to be on this campus. Again, we appreciate you wearing your ID as we ask you to. We're glad you're here this morning, and as we begin our day here on Friday, just want to have a couple of quick shout-outs this morning, and just let these people know that I'm going to announce that you really appreciate them. This is a time that we want to recognize them and thank them for their efforts. I want to send a special shout-out this morning to Officer Holland. He is consistently just helping us in the front door every day with welcoming students and joining me there at the front of the school, along with some of our other students. We've had a lot of other students, our ambassadors have helped us quite a bit with the welcoming, as well as Rico, so we appreciate your help. Again, Officer Holland, thank you for your help at the front door. And I want to say a special shout out this morning for all the work that you're doing in the attendance office. We appreciate this, Ms. Eustace, Ms. Geek, and Ms. Doyle. Thank you for your efforts in the attendance office, making it work for everybody here at our school. This concludes our morning update. I just want everyone to know we are glad you're here this morning, and I hope all of you have a great day here at AHS.
Okay, all right. So yesterday we started metamorphic. We did the formation. Today we're going to do textures, and then Monday we're going to do the specific types of metamorphic rocks. We'll review Tuesday. The test will be Wednesday, and then Thursday and Friday next week we're going to start up plate tectonics. Just sort of introducing it. I mean, because the next week is 6 weeks exams, so I'm going to have to start it. Okay, and then when we come back from Christmas break, we'll go a little bit more in depth, and then we'll do, they call it the ever-changing surface of the earth, or I'm not saying exactly right. I forget how they, something changing surface of the earth, and then we'll get into the history of life and evolution, all that good stuff. But for the opener, sounded like something in the chat. When is Christmas break? It starts what is that, the 18th? Is that Friday? That is a full day off. Double check. It's not a half day. It's a full day off.
Wait, Friday?
No, the 18th. So not next Friday. So the Friday after, the one that starts Christmas break.
Yeah.
That is a full day off. I double checked it because people were like, "Are you sure it's not a half day?" And I was like, "I don't think so."
Not. They're school taking half days. It's like, it's really hard to explain, what sort of, whenever, like, for the Thanksgiving, Christmas, we have half days. Now we don't have half days anymore because of the fact that it's easier not to have half days and just have full days, because then you'll get like a full day off in one of the months. So every month you'll get a full day off.
So basically, they took away half days and they merged it into a full day.
Yeah.
Okay. Okay.
So we're gonna have everything Friday on after.
No. No. We take.
No, I'm saying like if this corona was here, we'd have like half day on Thursday, half day on Friday.
No. No.
Even without it's
Yeah. They take that. A lot of stuff changed when they went from you had to have so many days for the school year to so many minutes of the school year, and that happened like I don't know, something like 4 years ago, give or take.
I was in seventh grade.
Oh, so I'm about right. I'm about right, give or take. All right, so anyways, yesterday when we started the metamorphic rock, we talked about foliated and non-foliated. Foliated, you see the sections, you can see the bands, and non-foliated, you can't. Do you know what the term foliated or foliage comes from? It's Latin, okay? It means leaf. Okay, that's why foliage on trees is called foliage. It means leaf. And so with these, especially with nice, which I don't know if I have any. Okay, so like this one this is slate, okay? It's a little dusty, okay, but it's not foliated. You can't see the bands in it. Whereas this one, and I know you guys can't see online, but we'll have pictures. You can see bands in it. So this is foliated. This is not foliated, or it's non-foliated. It's just really dirty. It needs to be cleaned. Oh, now my hands are disgusting. I'm going to freeze this. Once we get through with this, I'll let people know if they're missing stuff. I just went through right before you guys showed up, and I updated grades. In fact, I guess I can do it while let's see here. The one from 2 days ago, Otis, I know you're missing both assignments. Caitlin, if you're online, both assignments. This is yesterday and the day before. Esai yesterday, Taylor yesterday, Erica yesterday, Dylan yesterday, Decker yesterday, and Colton both. The stuff from the 30th and the 1st has been locked. I tell you guys every day if you're missing stuff and when you're running out of time. So if you did not listen to me, those 2 days, Monday and Tuesday, are now shut down. Unless if you've had like extenuating circumstances, massive absences that, you know.
What were you saying?
No, the one from yesterday is open. Okay, and then the one from 2 days ago, from Wednesday, is open until midnight. But that one's going to be shut. It's been the same thing. If you take a look at the assignment, it'll tell you that the due date's the next day. But then I put in +1 because I have so many students that have extended time by a day, so that's built into there. Anyways, metamorphic still needs to change form. This is just a refresher from some of what we were doing yesterday. And it could be any type of rock, as long as it is exposed to enough pressure with heat. If it's just pressure, it's not going to metamorphize. It's sedimentary if it's just pressure. The pressure and the heat without melting is going to make it metamorphic. And there's another flow chart if that helps you. Okay. Some of you, the graphic organizers, they help. So we'll be filling this in. I'm going back and forth. You'll have to use Cami to fill it in because the Google Docs they don't like using this text box, or I don't have the right app to be able to do it on or extension on my computer. So once again, I'm trying to help some of my students in my later classes pull out the important stuff. In order to be metamorphic and not sedimentary, they both have pressure, but the metamorphic has got to have some type of a heat exposure as well without melting. If it goes to the molten state, it starts back over as igneous. The rock cycle starts back over again. So this particular thing, if these do help you, what it means is to change form. And then on the right-hand side, metamorphic rocks are formed when all 3 types of rocks, could just be one, but it could be all 3 types of rocks are exposed to enough heat and pressure. It's like I said, that heat, if that's not there, it's not going to change form. It's just going to compress. And I'll come back at the very last slide, and I guess I animated that slide, so I'll have to go back and fix that. 2 major types of metamorphic, we mentioned them yesterday. It has to do with what it's made up of and its texture. Okay, and with metamorphic, a lot more of it is visual. So foliated, you can see these sections. You can see them, like I said, yes. Foliated essentially means leaf. Which I am not sure if all of these rocks are correct. Non-foliated, you're not going to see them because they're fine grained. And I have the paper that says what these supposed to be, but Miss Castleberry even came in and she's like, that's not what that is. I was like, yeah, I don't know who changed all the little stickers on them, little ID tags. This is pronounced nice, how it's pronounced. This is going to be your highest grade metamorphic rock. This is basically as hot as it's going to get before it melts. And these do have their up and down foliations, as you can see. Now, this particular type of rock has all different kinds of weird stuff that can happen with it. We'll come back at the end and we'll talk about what these eye spots are. I'm going to use some German words today, mixed in with the Latin. Foliated, the minerals are flattened and they're put into layers. You can see the layers. Like if you take a book, like not an electric book, a real book, and you turn it on the side, you can see the pages going up and down in the rock. 3 examples that we're going to say are we're going to use phyllite. I actually have phyllite and I have slate here. Slate looks like a chalkboard, like a blackboard. And it's going to cleave on very, very, very flat planes. This is a piece of slate. And then the next down the line, phyllite, looks similar. Sometimes it has almost looks like a shiny, waxy coating. This one doesn't. But they have these wavy marks in them called crenulations, which once again, those of you that are online, once we get down to these, when we talk about them Monday, there's pictures of all of them. Very, very, very fine grain with slate. This one is nice, is this one. I know it doesn't, this is literally pronounced nice. The G is silent, but you can see the up and down bands. Sometimes they're very, very, very thick. Sometimes they're distorted and they look wavy. This one does not. It has to do if there's plate tectonic, if there's active motion underneath it to cause the stress, to call those wavy lines, distorted shape. Okay, so we've got foliated. So they're flattened and pushed into layers. Oh, I forgot to animate the phyllite. Slate, nice, and phyllite. Need to go back. Whoops. Forget when I go too far down that black bar shows. Like, go away, black bar. So, and then we'll do non-foliated. This flow chart's actually a lot quicker than the other one was. But we need to come back and talk about specific textures that are not on this list. Non-foliated do not have layers. There's no banding, like sections, parallel sections. Quartzite is non-foliated. It can be made 2 different ways. It can be by contact heating from quartz, or it can be from heating of the sedimentary rock sandstone. There's multiple ways to make this particular type of metamorphic rock. Some of them only have one way, like hornfells. Hornfells are, and we'll talk about hornfells again. We talked about them yesterday. Hornfells are only made through contact metamorphism along the areoles, which is along the igneous intrusion. That you see that almost looks like little hairs that are sticking off the side of that thing. That's a hornfeld. That's what this is. Very, very, very brittle rock because it is extremely tough. And I know, I probably said this yesterday, it sounds like an oxymoron, but when the bonds between the atoms of inside the rock are very, very rigid, it makes it very, very brittle. And if I can make this animate, so I forgot to animate that part too. The coarse textured non-foliated rock is marble, and I do have a piece of marble in here. Should know what marble looks like. Sometimes marble has different colors in it, but this is a piece of marble. I would know that this is different from quartz because if I put hydrochloric acid on a piece of this, it's going to start bubbling. That doesn't happen with quartz. It happens with marble, not with quartz. So the big scare about acid rain when I was a kid, when you looked at like the gargoyles and like the statues on the side of older buildings, you could see that when we were having issues with acid rain, it was almost like it was trying to down. Not like into a puddle of goo, but you could see that it was eroding the finer features on the statues. Okay, now we talked about coal was sedimentary. And the beginning production of coal is sedimentary. It's bioplastic. You have plant material that starts breaking down. It creates some type of a peat ball, which then undergoes pressure, and it starts making the softer coals. If this is the softer coal. This is bituminous coal. If this now, I'll check that in a second. If this now is exposed to more heat, but not magma, but more heat, then it turns into the hardest coal, which is anthracite. So it has its origins with sedimentary. It comes from sedimentary, but that extra bit of heat is going to technically be metamorphic. Let me see if it was a person that came on. Oh, I do see somebody new. I see Natalie. It's actually the coolest of all of the metamorphized rocks. The hottest would be gneiss. Like not N-I-C-E, G-N-E-I-S-S. Okay, I think I got everybody now. And so once again, you've got more pressure, drives out the gases, compacts it more, and it makes it harder. And anthracite is the hardest of all of the clays. And so on the right-hand side, they do not have layers. Examples would be quartzite, marble, and anthracite coal. Yes, there are others. We'll go into a lot more of them on Monday. In fact, I may have to cut some of them out. But I may have given you too many examples. Foliated specifically, some of them have very specific types of cleavage. Now, when we did this back with the rock cycle, and when we did minerals, cleavage is the way that the thing wants to break. Sometimes on flat planes, sometimes in a cube, but the regular definition is just it's the way that specific rocks break apart. With slaty cleavage, which happens with slate, slaty cleavage, they want to cleave. I don't know how well, here we go, that's better. You can sort of see these parallel lines that are going down the edge of the slate. It wants to cleave in flat planes along that. In fact, both sides, you can see both sides of the slate are like perfectly flat. That's, well, no, you guys can't, if I gave it to you, I'm supposed to let you pass stuff around. But you can, I know, but still, we're not, like, I've had, between Monday and Wednesday, I had 16 students that had to go in quarantine, of my own students. I don't have many of you left. I have a class that has 4 in it right now. There's supposed to be 24 kids in there. I have another one that has like 8.
Technically, you touch stuff in acid.
Wait, what?
Like, you know, like some like cities you touch stuff like breathe it on. It's not criminal, so.
Yeah, it's supposed to be, it's too. But it's also, it's aerated also, so. I don't know. I don't want to be the person that's responsible for the spread, like, at least not knowingly. Ugh. I just want the virus to go away. Phylitic is going to have, in compared to the slate, this is a piece of phyllite. Now, there's different types of phyllite. This is specifically, from Vermont. Specifically came from Vermont. I don't know where in Vermont, but that's where it came from. And it is the next warmer version, if you will, the next down the metamorphic chain. It starts with shale, which is a sedimentary rock. When shale is exposed to more heat and pressure, it turns into slate. When slate is turned more heat and pressure, it's turned into phyllite. A phylitic is just the typical term for the coloration of this, not like the gray color, but like the slightly shiny color, the waviness that's on here, which are called crenulations. And you do see some grain with phyllite, whereas you don't necessarily see it, well, there's a little bit in here with the slate, but it's more pronounced with phyllite than it is with slate. I don't think there's a lot of Next thing we're going to talk about is the property of schist, schistosity. Okay, so schistosity is a property of the many different types of schist. You have definite bands with schist. You can see the layers with schist. Igneous. That's sediments. There's metamorphic. A lot of times you see small gemstones in it, specifically granite. In fact, I have granite schist up here. You want to look at them. That's igneous. Slates. And if I put it up in the light, I'll find the right one. Here it is. Okay, so this is garnet schist, and you can see those little circular things. Those are garnets. Very, very, very common with this particular type of rock. You can see the grain with these. In fact, with this one, it's going, the way I'm holding it, it's going up and down. And then the garnets are in between the layers of the rock. Sometimes they have mica in them, like this one, and you can see the shiny parts, which is the mica. All different kinds of stuff can be in schist. I said a bad word in German. I pronounced it the wrong way. This is a lot shorter than yesterday, and a heck of a lot shorter than Monday. I don't have quite as many images as I did yesterday. You know what, we're going too fast. Gneiss structure is a normal pattern, a texture with all types of gneiss. There's tons and tons and tons of it. Very large grains, and yes, it can look igneous. Very, very, very coarse grains means larger particles. Like we said, coarse does not mean rough with rocks. It just means bigger, but you can see the grain with the naked eye. Very banded appearance. If it's wavy, it is called folded. That has to do with tectonic motion. Gneiss is the very end of the chain with metamorphic rock, because any warmer than that, and it's going to cross that threshold for melting point, and you become magma. This would be the deepest of your metamorphic rocks. I've got pictures that are going to show all four of these side by side. I got them. All right, so slate is the top left. Slate and phyllite do look a lot alike. Phyllite does tend to be lighter in color, and it's not like oily shiny. It's waxy shiny. You've seen wax paper. It's not like going to blind you when the light bounces off of it, but you can see that it's got a different sheen to it. Schist is this one down here on the bottom left, which is what this is. This is a type of schist. You don't really see the garnets on this side. You see almost all of them on the back side. And then gneiss, if it's folded, then you have these curvy bands. If it's not folded, then they are straight bands or non-folded. Non-foliated metamorphic rocks where you cannot see layers. They have to be from high strain metamorphism. Lots and lots and lots of pressure. I don't think that one was on your notes. Now, granophyls are. Granophyls is a generic term for any type of metamorphic rock that is not foliated. It's just what it's called. Hornfels is very, very specific. So hornfels is this one. They're found right along the edges of those, the igneous intrusion. They are a contact metamorphic rock, extremely brittle. When I was holding this, I want to say it was second period, and I'm not holding it hard. There's one little section right here on the side where all I have to do is push on it and it's going to break off. All I did was pick it up and I had a piece of it break off and I was like, uh-oh. And once again, hornfels is like, and it's very shiny. Hornfels is like this because the grain inside the rock, the bonds between the elements inside the rock are extremely rigid. And the more rigid something is, the more likely it is to break. I don't know if you've ever been in a high-rise skyscraper, like 60-something stories up kind of skyscraper. If you're on a balcony way up there, if they have them, you open a window, well, those things sway back and forth. If they didn't have that flexibility, the whole top of the skyscraper would break off. It's the same, you laugh, it's what they do. They are built to sway, just like trees. You can see trees sway in the wind. I don't know if you guys have those big pine trees around here like I used to. If they can't move, they break. Now, you get a big enough storm and it's gonna snap off the top of the tree anyways. This exact same concept with a rock. It's not a tree and it's not a building, it's a rock. Extra terms that I have not figured out which of these I'm going to throw into the test yet, but porphyroblastic, you're going to have sections that are going to be larger than others. You can see them. Ovoid means like egg. You see spots. This is really, really, really common with gneiss. And I'm going to show you some pictures of it. Low-grade contact metamorphism, it means that it comes in contact with heat, but it's not super hot. Like I said, super hot is this hornfels. This is the one that they call a cooked rock. This is as hot as it's going to get with contact without actually turning back into magma. Low-grade contact just means, it's going to be exposed to heat from around that igneous intrusion, but it's on the cooler end of it. Go forward. This is an image of, I only know a few words in German. It's German for eye. It's all game. So I think it is all done. I have a student that he keeps talking to me in German, and I know a few German words, and I guess he thought that I was fluent in German. And I know he always says just as he walks by, which means bye in German. I know that. I got a cousin that lives in Germany. Second cousin. But these large eye-shaped grains, so if I come down here, this is what it's talking about. You see, like, people like this in their countertops in their kitchen. They like these patterns. Now, granite, though, is not metamorphic. Granite is igneous, so this is not granite. This is gneiss. This is ogden gneiss because it has these big spots in it. This is a metamorphic rock. This is not an igneous rock. A lot of times those big circular patterns, they do come from feldspar. They don't have to come from feldspar, but more often than not they do. And we have a couple more terms. I'm going to double check my attendance again. I'm going to double check people who, if you did the retest, because that shuts down at 4 o'clock. Uh-huh. I mean, I opened up the original test like 4 times, the one from the 20th, and I still had people that didn't take it. Last little one, there's not much on here. There are a couple of other prefixes. A parent rock is a protolith. Okay, it means first rock. That's the generic term for a parent. If it's an igneous parent, it's an orthoprotolith. Ortho is for igneous. If it's sedimentary as a parent, it's a paraprotolith. That is as geologically scientific phrase as I could ask that. Your layman's term would just be an igneous parent or a sedimentary parent. But if I said it the way that this is technically not a geology class, even though we're talking about rocks right now. If I wanted to be technical, it is a orthoprotolith, and you should know that that's from something like granite, okay? Or it's a paraprotolith, and that would be from something like sandstone. I have not officially written your test yet. I have pulled 30-something questions that I liked from the generator. I have not figured out how mean I'm going to be on this test. So let me see. Let me check real quick online. Make sure I got everybody that was here. Make sure they don't have any questions. Braylon, Chase, Courtney, Decker, Lisa, Joseph, Natalie, Sarah. Oh, something in the chat window. Oh, but I already answered that. Okay, so it is frozen, right? Okay, let me go back into the grade book. Oh, I'm in the wrong class. Let me do our space. That is, today was quite a bit shorter than yesterday, and right now Mondays are lengthy. I may cut out some of the types of rocks, the metamorphic rocks. I'll do that this weekend. I don't think I'm gonna have enough time to get to it. It's the wrong period. The first period. Okay, so once again in here, because I didn't have the openers. It says you made a 0 on that retest because I forced it out. Okay, so 11:30 and 12:01 are closed. Okay, so once again, the opener and the assignment from the second and the third, both of them, like all 4 parts, would be, I'm looking for them from you, Otis. The assignment from Caitlin on the second and the third. You did the openers, but not the assignment. I'm not even sure if she's online. Esai I saw online, and both of them from yesterday, which they're open. Taylor, both from yesterday, and the opener from what day was that? Tuesday? No, Wednesday. Erica, the opener from Wednesday, and both from yesterday. Courtney, the opener from yesterday. Kale, the opener from Wednesday, the second. You got all the other ones done. Dylan, the assignment from yesterday. Decker, the assignment from yesterday. And then Colton, I don't know if Colton's online or not. Everything from both days. And if I'm telling you that you missed doing something from the second, which was Wednesday, those do shut at 11:59. If you missed the one from yesterday, I think that one's open through Monday. I think. Here, let me double check it. Let me double check it on the. Yes, that's open until Monday at midnight, at 11:59. Do what?